Imagine a planet so colossal that more than 700 Earths could fit inside it, yet it's made almost entirely of gas. This is Saturn, the Lord of the Rings and one of the greatest enigmas of our solar system. Since Galileo first gazed upon it, what lies beneath its golden clouds has remained a riddle that both amazes and challenges human understanding. What we see through telescopes is just an illusion of shimmering gold. The true face of Saturn hides beneath endless layers of gas, clouds and raging storms that never cease. Down there, pressure and heat become so extreme that the very laws of physics start to bend, creating an alien environment unlike anything we can imagine. Unlike Earth, Saturn has no solid ground to stand on. There is no surface beneath its clouds, only a gradual transition between states of matter. Gas becomes liquid, liquid becomes metallic, and beyond that lies something entirely unknown. A descent into Saturn would be a one-way journey into the void. That's why Saturn is considered one of the most mysterious places in our solar system. What it hides in its depths might reveal not only how it formed, but also how all the giant planets, and perhaps the solar system itself, came to be. Human curiosity has always tried to see beyond the clouds. Every probe, every telescope, every bit of data collected represents another attempt to peel back the veil of this colossal world that refuses to give up its secrets. Images from NASA's Cassini mission revealed that Saturn is far more than a beautiful spectacle. Beneath its calm appearance lies a chaotic atmospheric system filled with motion, energy, and phenomena that scientists are still struggling to explain. What's even more fascinating is that Saturn shines with its own light. Despite being so far from the Sun, it emits more heat than it receives, a clue that something powerful is happening deep within. Perhaps the planet's interior is collapsing under its own gravity, or maybe something even stranger is going on. Each new discovery about Saturn seems to raise more questions than answers. What truly exists below the golden haze? Is there a solid core or just a vast metallic ocean swirling endlessly under pressure? This mystery fuels scientists and captures the imagination of anyone who gazes at Saturn in the night sky. It's as if the planet holds the silent memory of the universe itself, waiting to be uncovered. To understand Saturn is to understand ourselves, because to learn how this giant was born and what it holds inside is to uncover a chapter of the same cosmic story that gave birth to us all. The golden clouds of Saturn, what are we really seeing? When we look at Saturn, what our eyes perceive is only the outermost layer of its atmosphere, a delicate veil made of gas and tiny ice crystals. That golden, soft glow hides a world of unimaginable complexity beneath, a curtain concealing an abyss of storms and secrets. The planet's color comes from compounds like ammonia and ammonium hydrosulfide. When sunlight interacts with these chemicals, it paints the atmosphere in mesmerizing hues of gold, beige, and amber. The reason Saturn stands out as one of the most stunning objects in the cosmos. But those clouds are far from still. They are in constant motion, swirling into bands, vortices, and colossal storms that can circle the planet at over 1,000 miles per hour. Every golden stripe you see is a storm, some that have raged for decades, maybe even centuries. What's even more intriguing is that beneath those visible layers, completely different ones await, with drastic shifts in pressure, temperature, and chemical composition. Saturn is a cosmic onion, and each layer peeled away reveals a new, deeper mystery. Scientists believe that the visible layer of clouds is only about 60 miles thick. Beneath it, pressure rises so intensely that the gases start behaving like liquids, forming an invisible ocean of hydrogen and helium that stretches for thousands of kilometers. If we could dive into those clouds, the golden glow would quickly fade into darkness. Sunlight doesn't penetrate far beyond the upper layers, and soon the world would become a black sea of storms and lightning, roaring endlessly in the depths. These golden clouds are, in truth, Saturn's mask. Everything we see, ours, including its magnificent rings, floats above a bottomless storm of gas and energy, bound together by the planet's immense gravity. From a scientific perspective, Saturn is a planet that never truly reveals its face. Its clouds mark the fragile border between what is known and what remains unknowable, and that's precisely what makes Saturn so hypnotic. To look at it is to witness a living mystery, a celestial dance between chaos and harmony that defies comprehension. Behind every golden shimmer lies an unanswered question. And maybe that's Saturn's greatest secret. The more we learn about it, the more it slips through our grasp. The composition of Saturn's atmosphere. Saturn's atmosphere is a masterpiece of simplicity and chaos, made mostly of hydrogen and helium, the same elements that fuel stars. But within this familiar mix hides a strange balance of trace chemicals like methane, ammonia, and water vapor, each adding texture and behavior to this alien world. It's a chemical symphony that shapes the planet's colors, storms, and even its mysterious glow. From a distance, Saturn appears calm and uniform, but its gases are constantly shifting. The upper layers swirl in endless motion, driven by high-speed winds and temperature gradients that would shred any earthly storm apart. The deeper one goes, the denser and hotter it becomes, until the gas turns into something more like liquid metal. The boundary between gas and liquid is not a clean line, but a smooth, almost dreamlike transition. As pressure builds, hydrogen molecules are crushed so tightly together that they begin to act like metal, conducting electricity. Scientists call this strange substance metallic hydrogen, and it may hold the secret to Saturn's powerful magnetic field. Imagine floating through those layers. First, through thin, golden mists, then into thicker clouds of ammonia snow, and finally into a region so hot and dense that light itself would struggle to escape. Each step down is a descent through a new phase of matter where nothing behaves the way it should. Even the simplest questions about Saturn's atmosphere remain unsolved. How deep do the winds go? How stable are the layers beneath the visible clouds? Some models suggest that Saturn's winds could extend thousands of kilometers into the planet's interior, powered by hidden heat sources. The deeper regions of Saturn are completely invisible to us. No light reaches them, and no instrument has yet survived long enough to measure them directly. Everything we know comes from indirect observations, gravity readings, temperature models, and the faint signatures of radio waves. And yet from these clues, a portrait begins to emerge. Saturn may not have a surface, but it has depth. Immense, layered, and dynamic. It is a planet built on transitions, gas into liquid, light into darkness, and certainty into mystery. The chemical makeup of Saturn's atmosphere also tells us something profound about its past. Its abundance of light elements suggests it was one of the first planets to form after the Sun, capturing the leftovers of the young solar nebula before they drifted away. This means that Saturn is, in a sense, a time capsule, a frozen echo of the early solar system. To study its atmosphere is to peer billions of years into the past, into the raw materials that once built worlds. Every molecule of hydrogen and helium in those clouds once floated freely in the chaos of creation, and now they swirl together in golden harmony, whispering stories from the dawn of time. The colossal storms of the hexagon. At Saturn's north pole lies one of the most extraordinary phenomena in the solar system, a storm shaped like a perfect hexagon. Stretching over 30,000 kilometers across, this colossal system could easily swallow the entire Earth. Its geometric precision has baffled scientists since it was first discovered by the Voyager missions in the 1980s. The hexagon is not a solid structure but a moving pattern, a standing wave of wind circling the pole at incredible speeds. Each of its 6 sides is formed by jet streams that rotate at different velocities, somehow locking together into a shape that has remained stable for decades, perhaps centuries. Inside the hexagon lies an enormous hurricane with a dark, circular eye at its center. Unlike hurricanes on Earth, which fade when they lose access to warm oceans, Saturn's polar storm never stops. It is sustained by the planet's internal heat, drawing energy from the depths rather than from the sun. The winds there reach speeds of over 500 kilometers per hour, carrying with them ammonia ice and other exotic particles that form intricate cloud patterns. Seen from space, it looks almost unreal, like a cosmic whirlpool sculpted by mathematics itself. Scientists believe the hexagon forms because of the balance between Saturn's rotation and its atmospheric layers. The planet spins so quickly that a day lasts only about 10.5 hours, creating powerful jet streams that bend and fold the atmosphere into strange, repeating shapes. But even with simulations, no one has been able to recreate the exact conditions of Saturn's hexagon in a laboratory. It's a puzzle that defies replication. A reminder that nature still holds designs we can't yet fully grasp. What's even stranger is how stable it is. Over decades of observation, the hexagon has barely changed shape. Its colors shift with the seasons, but its structure remains intact like a symbol carved into the planet's north pole. The hexagon is not just a storm, it's a window into Saturn's inner dynamics. It hints at deep processes beneath the clouds where layers of gases interact under immense pressure to create patterns of unimaginable scale. To understand that hexagon is to understand how order can emerge from chaos, how the dance of turbulence and rotation can produce something so precise and eternal. And perhaps, in that swirling geometry, Saturn reveals something poetic, that even in the vastness of the cosmos, there is beauty in the patterns of the storm, the crushing pressure. Beneath the clouds. The deeper you travel into Saturn, the heavier the world becomes. Every kilometer below the clouds adds layers of gas pressing down from above, until the pressure is beyond imagination. It's not a place any spacecraft could survive. Within minutes, it would be crushed flatter than paper under the weight of Saturn's own atmosphere. At just a few hundred kilometers down, the pressure is already dozens of times greater than that on Earth's surface. By the time you reach deeper layers, it rises to millions of times our normal air pressure. It's a world where even atoms are forced into shapes they were never meant to take. This unimaginable pressure changes everything. Hydrogen, the simplest and most common element in the universe, begins to behave like metal. Electrons are squeezed so tightly that they can move freely, turning Saturn's interior into a giant, churning conductor of electricity. In that crushing environment, heat builds relentlessly. Temperatures soar to tens of thousands of degrees, hot enough to vaporize most known materials. If there were a probe descending through Saturn's atmosphere, it wouldn't simply melt, it would dissolve into its surroundings, becoming part of the planet itself. It's strange to imagine. Beneath those calm, golden clouds lies an inferno of invisible violence. Pressure and temperature twist matter into new forms, transforming familiar gases into liquids and metals in a silent, eternal struggle. The deeper you go, the less the concept of sky or space makes sense. There is no clear boundary, no moment where air becomes ocean. It's a continuous plunge through layers that grow denser, darker, and hotter with every passing kilometer. Scientists often describe Saturn's interior as a world without a surface. There's nowhere to land, no ground to stand on, only a slow drift toward crushing pressure and blinding heat. It's not like falling onto a planet, it's like being swallowed by one. Understanding Saturn's pressure isn't just about knowing what's inside it. It's about unlocking the physics of giant planets everywhere, from Jupiter to exoplanets that orbit distant stars. What happens under Saturn's clouds may be the same story repeating across the cosmos. Every model scientists build to simulate Saturn's interior has to account for this immense compression. It's not just a question of chemistry, it's about how matter itself behaves when pushed to its absolute limits. In those unimaginable depths, Saturn becomes not just a planet, but a laboratory of extremes, a place where the universe experiments with the very structure of reality. The boundary between gas and liquid, somewhere deep inside Saturn, the gas stops behaving like gas. The molecules, crushed together by endless pressure, lose their freedom to float and begin to move as a single, dense fluid. It's a transition that has no sharp edge, no surface, no splash, just a gradual fading of one state into another. Scientists call this strange region the gas-liquid boundary. It's where the outer hydrogen atmosphere starts merging into the metallic ocean beneath. This metallic hydrogen is thought to extend across a vast layer that may surround Saturn's mysterious core. What's astonishing is how smooth the transformation is. There's no clear line, no visible event, only a slow, graceful blending of gas into liquid as pressure and temperature rise. Saturn doesn't have borders, it has gradients, transitions, and transformations. In this region, hydrogen behaves in ways we can barely replicate on Earth. When compressed enough, it becomes so dense that it reflects light like metal. Inside Saturn, this reflective layer could help trap heat and explain why the planet emits more energy than it receives. To visualize it, imagine falling through endless clouds until the air becomes thicker, not suddenly but gently, until it feels like swimming through a sea of invisible liquid. There are no waves, no surface tension, just an infinite ocean of shimmering pressure. This strange, metallic world is also the birthplace of Saturn's magnetic field. As hydrogen turns metallic, it conducts electricity, and the planet's rapid rotation turns it into a dynamo. The result is a magnetic field so perfectly aligned with its axis that it still puzzles scientists today. It's possible that beneath this metallic ocean lies the planet's elusive core, a dense mix of rock, ice, and heavy elements crushed into something we've never seen before. But no probe has ever gone deep enough to confirm that theory. For now, the core remains a shadow at the bottom of a storm. Studying the gas-liquid boundary isn't just a question of curiosity. It's a key to understanding the birth of planets themselves. The behavior of matter under these pressures determines how giants like Saturn and Jupiter formed billions of years ago. In a way, Saturn's interior is still forming, still shifting and balancing the energy that drives its endless storms. It's a living process, frozen in motion, but alive in complexity. To fall into Saturn would be to fall across every known form of matter, gas, liquid, metal, and perhaps something beyond. It's not just a planet. It's a transition zone between the ordinary and the impossible, the metallic core. Hypothesis. At the center of Saturn lies one of the greatest mysteries in planetary science, a question that remains unanswered even after decades of exploration. Does Saturn have a solid core? Some scientists believe that deep beneath the metallic hydrogen lies a dense, rocky heart roughly 10 to 20 times the mass of Earth. Others think it may be a soft, fluid blend of ice and heavy elements instead. This uncertainty arises because no spacecraft has ever been able to see that far. Even Cassini, one of the most advanced missions ever sent to the planet, could only infer the existence of a core from gravitational data. Saturn's layers are so thick, so extreme that light and sensors cannot reach them. Everything we know about its center is a calculated guess. If Saturn does have a core, it was likely the seed from which the planet grew billions of years ago. In the early solar system, icy rocks would have clumped together, forming a solid mass large enough to attract gas from the surrounding nebula. Over time, that process built the second largest planet we know today. The temperature at Saturn's center might reach more than 20,000 degrees Celsius, nearly as hot as the surface of the Sun. Under that unimaginable heat and pressure, materials behave in ways we can't easily predict. Rock and metal might not be solid or liquid, but something in between, a molten, dense plasma of elements forced into coexistence. Some models suggest that the core isn't stable at all. It could be dissolving slowly into the surrounding metallic hydrogen, creating a gradient of heavy elements that mix upward. This fuzzy core hypothesis is one of the most intriguing ideas about Saturn, that the planet's heart may be melting into its own body. If true, that process would have major implications for how gas giants evolve. Saturn might be gradually reshaping itself from the inside out, redistributing its weight and energy. In a sense, the planet would be alive, not in a biological way, but in a geophysical one. The magnetic field of Saturn offers another clue. It is remarkably symmetrical, so perfectly aligned with the planet's rotation that it's almost unnatural. That could mean the metallic hydrogen layer generating it is deeper and smoother than in Jupiter, perhaps influenced by a less defined core. To scientists, the idea of a fuzzy or dissolving core challenges traditional definitions of planets. Saturn might not be a world with a solid heart, but a gradient of matter, a continuum from heavy to light, from dense to ethereal. And that makes it even more mysterious. Because at its deepest point, where matter is crushed beyond recognition, Saturn may not have a true center at all, only an endless descent into increasing density. The further we peer into Saturn, the less certain we become. But maybe that's the beauty of it, a reminder that even in an age of advanced science, the universe still keeps its secrets close to its core. Comparing Saturn to Jupiter-Saturn and Jupiter are often called siblings, the twin giants of our solar system. Both are made mostly of hydrogen and helium, both radiate more heat than they receive, and both dominate their surroundings with immense gravitational power. Yet when you look closely, Saturn is not just a smaller version of Jupiter, it's an entirely different kind of giant. For one, Saturn is far less dense. You could drop it into a cosmic ocean and it would float, the only planet in our solar system light enough to do so. This low density comes from its smaller core and thicker outer layers of gas, which make it more delicate in structure compared to Jupiter's more compact build. While Jupiter's storms are violent and short-lived, Saturn's are slow and majestic. Its atmosphere is colder and calmer, with vast layered cloud systems that stretch for thousands of miles. Even its winds, though ferocious, flow in smooth bands, giving the planet an appearance of elegant serenity. Jupiter's Great Red Spot is a chaotic storm that has raged for centuries, but Saturn's hexagonal storm is geometric and ordered, a structure of perfect mathematics. Where Jupiter shows nature's chaos, Saturn reveals its symmetry. Their cores may also tell different stories. Jupiter's gravity suggests a relatively small and solid center, while Saturn's may be larger, softer, or even dissolving. If true, Saturn could represent a later stage in the life of a gas giant, a planet still evolving, reshaping itself with time. Even their magnetic fields differ dramatically. Jupiter's is intense and chaotic, while Saturn's is smooth and nearly aligned with its axis. That perfection, oddly enough, confuses scientists. It may mean Saturn's field comes from deeper layers of metallic hydrogen, distributed more evenly than Jupiter's. The two planets also form a delicate gravitational partnership. Saturn's orbit and Jupiter's influence together shape the architecture of our solar system. Without them, many smaller bodies, including Earth, might not have survived the chaos of early planetary formation. In many ways, Jupiter represents power, Saturn represents balance. One is a roaring forge, the other a silent symphony. Together they embody two faces of the same cosmic principle, creation through extremes. Studying both side by side allows scientists to test their theories about how planets grow, evolve, and age. Each discovery about one inevitably leads to questions about the other, like two halves of the same equation. And perhaps that's the greatest lesson Saturn offers, that even in a family of giants, diversity reigns. No two worlds, no matter how similar, are ever truly the same. And that's what makes the cosmos endlessly fascinating. The role of internal heat. Despite being almost 1 billion miles from the Sun, Saturn glows faintly with its own warmth. It emits nearly twice as much energy as it receives, a mystery that has intrigued scientists for decades. This internal heat is not just a curiosity, it's a key to understanding how the planet lives, breathes, and evolves from within. Unlike smaller rocky planets, Saturn doesn't store heat from sunlight in its surface. Instead, it generates energy deep inside where immense pressure and gravity compress the planet's hydrogen layers. This process, called Kelvin-Helmholtz contraction, slowly releases gravitational energy as heat, turning Saturn into a self-warming world. But that isn't the whole story. Observations show that Saturn emits more heat than this process alone can explain. Something else must be happening deep within, perhaps a hidden mechanism that stirs and redistributes energy throughout its layers. One leading theory involves helium rain. As Saturn cools, helium droplets may condense out of the atmosphere and sink toward the core, releasing heat as they fall. This rain could power the planet's glow for billions of years, acting as a slow, eternal engine. If true, it means Saturn's atmosphere isn't just a passive layer of gas. It's alive with movement and transformation. Every drop of helium falling inward adds to the rhythm of the planet, turning simple physics into cosmic art. This internal heat may also be the reason for Saturn's fierce winds and constant storms. The planet's energy escapes unevenly, fueling colossal tempests that ripple across its surface in shimmering waves of gold and shadow. The concept of Saturn glowing from within carries something poetic. It suggests that even in the darkest corners of the solar system, warmth can come from within. A reminder that not all light comes from the Sun. Scientists studying this phenomenon see Saturn as a laboratory of thermodynamics on a planetary scale. Its heat patterns challenge models of planetary evolution, forcing us to rethink how giant worlds manage energy across billions of years. Every bit of warmth radiating from Saturn today is a whisper from its past, a remnant of the time when the solar system was young and chaotic, still glowing with the fires of creation. And as that warmth drifts through space, it carries a silent truth. Saturn is not a cold world at all. It is a planet that burns gently from within, sustained by the slow heartbeat of its own gravity. Revealing Saturn's secrets, the Cassini mission. No human has ever been to Saturn, yet we've seen it up close, through the eyes of a machine. Launched in 1997, NASA's Cassini spacecraft traveled for 7 years before reaching the planet, where it spent more than a decade unraveling its mysteries. Its journey transformed our understanding of Saturn forever. Cassini orbited the planet 294 times, flying through its rings, observing its moons, and diving between them with breathtaking precision. It sent back more than 600 gigabytes of data, a treasure trove that scientists are still studying today. Through Cassini's lens, Saturn became more than just a distant sphere of gas. it was revealed as a world of motion and texture, filled with storms, auroras, and structures so complex they seemed almost alive. Its rings, once thought to be simple sheets of ice, turned out to be dynamic systems shaped by invisible gravitational dances. One of Cassini's greatest achievements was mapping Saturn's gravitational and magnetic fields. By studying how the spacecraft was tugged by the planet's mass, scientists inferred details about its internal structure, clues pointing toward that elusive, possibly fuzzy core. The spacecraft also captured the first clear images of the hexagonal storm at Saturn's North Pole, watching its colors shift with the seasons. It became an icon of order within chaos, a perfect geometric vortex on a planet made of gas. Cassini's final act was also its most dramatic. In 2017, with its fuel nearly gone, NASA commanded the spacecraft to dive into Saturn's atmosphere, sending back data until the very moment it disintegrated. It was a deliberate end, a plunge into the world it had studied so long. During that descent, Cassini sampled the upper atmosphere, analyzed its composition, and measured pressure and temperature until it was swallowed by the planet. In those final seconds, it became part of the very world it sought to understand. The data from that descent remains priceless. It confirmed the depth of Saturn's atmosphere, hinted at complex interactions between its layers, and showed that the planet's chemistry is still changing. Cassini's death gave life to decades of future research. Even now, every new discovery about Saturn traces back to Cassini's journey. The spacecraft didn't just send back information, but it gave humanity a relationship with a planet we had only dreamed about. In the end, Cassini didn't simply study Saturn, it joined it. Its atoms now drift within the planet's clouds, circling forever in the golden storms of the giant it once orbited. Saturn's magnetic field. Invisible, silent, and immense. Saturn's magnetic field is one of the most perfect in the solar system. Unlike Earth's, which wobbles and shifts, Saturn's field is astonishingly symmetrical, aligned almost exactly with the planet's rotation axis. It's as if the planet were wrapped in an invisible sphere of magnetism, flawless and calm. This perfection is actually a problem. According to physics, magnetic fields shouldn't be perfectly aligned. They need a tilt to exist. So how can Saturn sustain such a balanced field? It's a question that has baffled scientists for decades, forcing them to rethink how dynamos, the processes that generate planetary magnetism, actually work. The source of Saturn's magnetic field lies deep inside, where hydrogen transforms into its metallic form under immense pressure. In this liquid metal ocean, electrical currents flow as the planet spins rapidly, creating a self-sustaining magnetic force that extends millions of kilometers into space. Cassini's instruments detected that this field remains surprisingly constant, varying little over time. That stability suggests something unique is happening inside Saturn, perhaps a deep, uniform layer of metallic hydrogen, or an unusually smooth transition between the core and the outer layers. If Saturn's core is fuzzy, with elements gradually blending rather than forming sharp boundaries, that could explain its magnetic perfection. The smoother the flow of material, the more uniform the electric currents, and the more symmetric the magnetic field. Saturn's magnetosphere, the region dominated by its magnetic field, is enormous. It stretches far beyond the planet's rings, capturing charged particles and guiding them into bright auroras that dance at the poles. These light shows are unlike anything on Earth, vast, shimmering halos of energy spiraling above the clouds. What's fascinating is how quiet Saturn's magnetic field appears compared to Jupiter's. Jupiter's magnetosphere crackles with radiation and storms, but Saturn's is serene, even graceful, a reflection perhaps of the planet's slower, steadier heartbeat. Understanding Saturn's magnetism could also reveal how magnetic fields shape other worlds. The same principles that govern this gas giant may operate in exoplanets orbiting distant stars, unseen but equally magnetic. Saturn's magnetic field acts as both shield and storyteller. It protects its moons, influences its rings, and preserves a record of the planet's internal motion, an invisible echo of what happens deep within. And in that quiet perfection, Saturn whispers a cosmic paradox. Even the most balanced systems in the universe are born from unimaginable forces of chaos and heat, unsolved mysteries. Is there a solid core? After centuries of observation, the heart of Saturn remains hidden, a mystery that refuses to yield to even the most advanced instruments. Beneath its golden clouds, scientists believe there may be a solid core, or perhaps something far stranger, a fuzzy core that blurs the line between solid and liquid. The evidence is indirect but compelling. Tiny variations in Saturn's gravity, measured by Cassini, suggest the presence of dense material near the center. But the readings don't fit a clear pattern, as if the planet's interior was softer and more fluid than expected. If Saturn once had a solid heart, it may now be dissolving. Heavy elements could be slowly mixing upward into the surrounding metallic hydrogen, creating a gradient that diffuses what used to be a clear boundary. In this model, Saturn's core isn't disappearing, it's spreading, becoming part of the planet itself. This core erosion idea is revolutionary. It means that Saturn isn't a static world frozen in time, but a dynamic one still evolving from the inside out. The planet we see today may be very different from the one that formed 4.5 billion years ago, but why does it matter whether Saturn has a solid core? Because the answer shapes our understanding of how giant planets form. A solid core supports the core accretion theory, the idea that gas giants began as rocky embryos that pulled in gas from the solar nebula. A fuzzy core, on the other hand, supports the idea of direct gravitational collapse. If Saturn's heart is dissolving, it might represent a middle stage between those two processes, a world transitioning from solid beginnings to fluid maturity. That would make Saturn not just a planet, but a time lapse of planetary evolution, frozen in motion. Even with all our technology, the question remains unresolved. No probe has ever ventured deep enough to confirm the state of the core, and likely none will for decades. Every answer we have comes from mathematical models shaped by the faint whispers of gravity and magnetism. Some scientists even wonder if the idea of a core is too human. Maybe in Saturn's case, there is no single heart, only layers of matter blending endlessly, a cosmic metaphor for unity and transformation. One day, a new generation of probes may dive into Saturn's depths, armed with technology capable of reading its interior like a map. Until then, its core will remain what it has always been, the planet's ultimate secret. Perhaps that's the allure of Saturn, that it reminds us not everything in the universe is meant to be known. Some mysteries exist to keep our curiosity alive. Falling into Saturn, a hypothetical journey. Imagine standing on the edge of Saturn, not its rings, not its moons, but at the very top of its golden clouds. You look down and see only endless haze, fading from gold to brown to black. There is no surface, no horizon, only an infinite descent into shadow. Now imagine stepping forward and falling. The first few moments would feel strangely peaceful. You'd drift through the upper atmosphere, surrounded by ammonia crystals glimmering like frozen sunlight. The air would be thin, frigid, and eerily silent. Around you, the winds would rage at over 1,000 kilometers per hour, yet the motion would feel smooth, almost dreamlike. As you fall deeper, the sunlight fades, the air grows denser and darker, until every breath would crush your lungs. The pressure here is already dozens of times greater than on Earth, enough to shatter any spacecraft that dares to follow. And yet, this is still the shallowest part of Saturn's immense ocean of gas. Soon, the temperature begins to rise, first warm, then blistering. The atmosphere, once cold and soft, turns into a searing fog of hydrogen and helium. Metal components would melt, circuits would fail, and any machine or human would dissolve into the air itself. But the fall continues. The deeper you go, the more surreal it becomes. Gases no longer act like gases. Hydrogen begins to flow like liquid, shimmering like mercury. You are now inside Saturn's metallic sea, a place where light bends and sound moves faster than on any world we know. In this layer, the pressure becomes incomprehensible. Every atom is crushed so tightly that electrons move freely, turning the fluid metallic and reflective. Lightning storms might flash somewhere nearby, invisible in the blackness, their energy rippling silently through the liquid metal. If you could somehow survive this deep, you might see the planet's magnetic field at work. Invisible currents swirl around you, driving Saturn's perfect symmetry, connecting the heart of the planet to its vast halo of radiation and rings. You'd be falling for hours, maybe days, yet never reach a surface. There is no ground in Saturn, no bottom to stop your descent. You would simply sink into higher density until your molecules became part of the planet itself. At the deepest depths, where the heat could rival the surface of the sun, perhaps there lies something solid, a molten, metallic heart buried under unimaginable pressure. But no probe has ever seen it, and maybe none ever will. Your fall ends not with an impact, but with transformation. You do not crash, you dissolve, you merge, you become Saturn. And in that final moment you realize, falling into the giant is not an ending, but a return to the same cosmic matter that built everything, even you. The future of Saturn exploration. Cassini may be gone, but Saturn's story is far from over. The data it sent back still fuels discoveries today, and scientists are already dreaming of the next great mission to the ringed planet. Each unanswered question about its core, its storms, its moons, is a promise waiting to be fulfilled. Future missions will likely focus on diving deeper than ever before. Engineers are designing probes capable of surviving Saturn's crushing pressure, equipped with instruments to measure temperature, density, and chemical composition in real time. The goal, to glimpse the mysterious boundary where gas becomes liquid metal. Some of these ideas go beyond orbiters. They include balloon probes capable of floating through Saturn's upper atmosphere for months. These aerial explorers could drift between storms, analyzing clouds and wind patterns like never before, sending data directly to orbiting satellites above. Saturn's moons will also play a key role in the next era of exploration. Worlds like Titan and Enceladus hold vast oceans beneath their icy crusts, places where life might exist in forms completely alien to us. By studying them, scientists could uncover how Saturn's gravity shapes environments capable of nurturing biology. NASA and ESA have already begun designing future missions to revisit this giant. Proposals like Saturn Probe and Dragonfly, which targets Titan, are part of humanity's growing effort to explore the outer solar system, not as distant objects, but as living laboratories of cosmic evolution. The biggest dream, however, remains to send a probe into Saturn's depths, one that can transmit data long enough to pierce the unknown. The first glimpse of its deep metallic hydrogen or its fading core would mark a turning point in planetary science. Beyond scientific curiosity, Saturn represents something deeper. It's a symbol of patience, of how much we can learn from a world we may never touch. Each new mission adds a brushstroke to a portrait that will take centuries to complete. Exploring Saturn also pushes technology itself. The materials, energy systems, and AI needed to survive its conditions will shape the next generation of interplanetary explorers, both robotic and someday human. When we return to Saturn, it won't just be for answers. It will be to witness the poetry of science, to stand again on the edge of the unknown and ask, as we always have, what lies beyond. And one day, as another spacecraft descends into those golden clouds, we'll watch it vanish and know that, like Cassini, it isn't dying. It's becoming part of the story it was sent to tell. What Saturn teaches us about the birth of giant worlds. In the end, Saturn is not just a planet. It is a story written in clouds and hydrogen, carved by time and gravity, told through storms that have raged for billions of years. To look at Saturn is to look backward into the ancient blueprint of how worlds are born. Every detail of the planet, its rings, its atmosphere, its heat, is a record of creation. Saturn's gases are the leftovers of the same cosmic cloud that formed the Sun and Earth. Its core, whether solid or fading, carries the fingerprints of the first moments when chaos began to take shape. By studying Saturn, scientists have learned how gas giants form, through the gathering of dust, rock, and ice into a seed that draws in the surrounding hydrogen of the solar nebula. Over millions of years, this process builds something colossal, a world too large to have a surface, yet still bound by gravity's gentle hand. But Saturn's lessons go beyond science. Its perfection, its beauty, and its mystery reveal how order and chaos coexist in the universe. It shows us that even within endless storms, patterns emerge, proof that the cosmos is not random, but rhythm in motion. When we compare Saturn to Jupiter, we see the diversity of creation itself. Two planets made from the same elements, yet with entirely different personalities. One, a roaring furnace of energy, the other, a quiet symphony of balance and grace. Saturn also reminds us that planets are not static. They change, breathe, and evolve long after their formation. Its glowing heat, its dissolving core, its shifting rings, all tell the story of a world still becoming. The more we learn about Saturn, the more it becomes a mirror. Its immense layers of gas reflect our own search for understanding, our desire to find structure in mystery and meaning in the infinite. Studying Saturn is, in a way, studying ourselves. Fragile beings floating in the same vast sea of cosmic matter. And yet there's something humbling about it. For all our knowledge, we still don't truly know Saturn. Its depths remain silent, its heart unmeasured, its secrets untouched. It stands as a reminder that wonder is not what we've solved, but what we can't yet explain. In the grand design of the universe, Saturn teaches us that creation is not a single event. It is a constant act. Worlds are still being made, stars still igniting, and life still forming somewhere in the distance. The cosmos, like Saturn, never stops. So when we gaze at the planet's rings through a telescope, we're not just looking into space, we're looking into time itself. Into the echo of beginnings, the rhythm of evolution, and the promise that no matter how much we learn, the universe will always have another secret waiting beneath the clouds.